Colin Ware, Visual Thinking for Design, the daily choices that define us. Have you ever wondered why people pass over designs you spent hours perfecting? You spent countless hours tweaking colors, adjusting layouts, and perfecting every detail, but somehow they still don't grab attention. Well, it turns out the reason might surprise you. The key here is understanding how human vision actually works, and that's exactly what you'll learn in this blink. You'll discover why our brains process visual information like search engines, how to make important elements instantly pop using basic visual features, and why the most powerful communication combines words and images strategically. Whether you're designing websites, presentations, or infographics, these research-backed insights will transform how you approach every visual challenge. If you're ready to stop guessing what works and start designing with the brain's natural patterns in mind, then let's get right into it. To see or not to see? There's something fascinating about the way we experience vision. We feel like we see the world in vivid detail, but we often miss obvious changes right in front of our eyes. This is because our impression of perceiving our surroundings fully and clearly is just that, an impression. Science reveals the startling truth. At any moment, you're only seeing a tiny fraction of what's actually there. This was shown in a mind-bending experiment by psychologists Daniel Simons and Daniel Levin. In it, a researcher approaches someone on the street asking for directions. Mid-conversation, two workers carrying a large door walk between them, and in that brief moment, a completely different person replaces the original researcher. Shockingly, over half the people giving directions never notice they're suddenly talking to someone else entirely, even when the replacement has different hair, clothes, or gender. This phenomenon reveals how human vision actually works. Rather than constantly processing everything around us, our visual system operates more like a search engine, retrieving specific information only when we actively seek it. We sample only the specific information required for our current task, creating what researcher Kevin O'Regan calls just-in-time vision. The world itself becomes our memory. We don't store everything internally because we can quickly access whatever we need through rapid eye movements. This discovery revolutionizes how we should approach design. Instead of assuming people will notice every detail, effective designers must understand that users will likely only pick up on key elements of a design. Take the famous London Underground map. When planning a journey, riders don't absorb the entire map at once. Instead, they execute a sequence of focused searches, first locating their starting station, then finding their destination, then tracing the colored lines between them. The map's genius lies in supporting these specific visual tasks through clear color coding and simplified geometry. So, what's the practical lesson here? Well, for anyone creating visual communications, start by identifying what visual questions your audience needs to answer. Then design specifically to support those queries. Whether you're creating a website, presentation, or infographic, success depends not on making everything visible, but on making the right information easily findable when needed. Making things pop. Take a moment now to imagine searching for your red car in a busy parking lot. It probably jumps out at you immediately among hundreds of other vehicles. But looking for your grey Honda among many similar grey cars, you'll spend the whole day running around the parking lot. This difference reveals another important aspect of how human vision actually works. Our brain processes visual information through specialized areas that act like filters. These filters are each looking for specific features across our entire visual field at the same time. Basic elements such as colors, line angles, object sizes, and movement patterns. Psychologist Anne Treisman discovered this through clever experiments. When people searched for a red circle hidden among blue circles, they found it instantly. Whether there were 5 or 500 blue circles didn't matter. The red target seemed to jump off the page automatically. But searching for a red circle among both red squares and blue circles took much longer, requiring people to examine items one by one. The key insight here is that our visual system can rapidly detect differences in single basic features. When something stands out in color, size, orientation, or movement from everything around it, it gets flagged for immediate attention. The brain essentially prioritizes certain types of visual information, making those objects much easier to spot. However, searching for combinations of features, like something that's both red and circular, requires more complex brain processing that works much slower. These searches can take 10 times longer because they need focused attention on each individual item. What does this mean for good design? Instead of trying to make everything equally visible, focus on making important elements distinctly different from their surroundings using basic visual features. Use clearly different colors, sizes, or shapes for items that need to be found quickly. If multiple elements need to be easily searchable, assign each type a different visual characteristic. Perhaps bright colors for one category and distinctive shapes for another. This prevents visual competition between important elements. Keep in mind also that movement creates the strongest attention-grabbing effect. Our brains evolved to notice motion in our peripheral vision as a survival mechanism, making it nearly impossible to ignore. That's why those animated online ads are so incredibly annoying. So, rather than working against the principles of human attention, work with them. By doing so, you'll level up your visual communication tenfold. Thriving in a 2D world. Looking around you right now, your brain performs an incredible task. It transforms countless visual fragments into recognizable objects and clear patterns. You're not perceiving something white, gray, and cylindrical with black symbols. You're seeing a coffee cup that reads, "World's Greatest Dad." Understanding this visual process changes how we think about good design. This is because vision works differently than you might expect. Though we move through a three-dimensional world, our eyes don't really operate on 3D vision, more like 2.5D. Our visual system prioritizes up and down and left and right over depth perception. This makes sense because moving your eyes gives you fresh visual data on up, down, left, or right almost instantly. Getting fresh data on near and far requires moving your body, sometimes a lot. That's why our brains are optimized to rapidly pass two-dimensional shapes, patterns, contours, and regions. We're great at quickly discerning boundaries between areas based on contrasts in color, texture, or feature alignments. Meanwhile, determining depth relationships requires slower, more effortful processing. This difference makes flat, image-based patterns especially powerful for communication. Your brain creates patterns through a process where individual cells in your visual system work together. When cells detect edge pieces that seem to belong to the same object, they coordinate their signals while quieting cells that detect unrelated fragments. This teamwork transforms scattered visual information into unified objects. These insights have real design applications. Rather than depending on complex symbols or labels, designers can use the brain's natural grouping tendencies. When elements share basic visual qualities like color, direction, texture, or movement, your brain automatically processes them together. But there are important limits. While simple features create instant grouping, complex patterns need step-by-step examination. This explains why finding a specific letter in text takes longer than spotting a red circle among blue ones. So experiment with building visual hierarchies that guide attention smoothly. Use separate visual approaches for different information types. The key is organizing information to match how the brain's pattern detection systems naturally work, creating pathways that feel effortless and intuitive to follow. Color Theory 101. Why do tigers have such vivid orange and black stripes? The answer is not what you might think. Those bold patterns aren't designed for us to see them clearly. In fact, most of the tiger's prey, like deer and zebras, have only two-dimensional color vision and see the world in grayscale. The stripes work perfectly as camouflage for them. Us humans, with our three-dimensional color vision, can spot tigers easily because we evolved as fruit-eating omnivores who needed to distinguish ripe red berries from green leaves. This insight comes from understanding how our eyes actually process color, knowledge that's revolutionary for anyone designing visual information. Your retina contains 3 types of cone cells that detect short, medium, and long wavelengths of light. But here's the key. Your brain transforms these signals into 3 opponent channels: red-green, yellow-blue, and black-white, perceived as luminance. This biological reality creates strict rules for effective design. The most important principle: always use luminance contrast for detailed information. Your brain's luminance channel handles fine details, motion, and three-dimensional shape perception, while the color channels cannot. This means small text must have strong light-dark contrast to be readable. Yellow text on white backgrounds fails miserably, while black text on yellow backgrounds works beautifully. For color coding, stick to what are known as the unique hues: red, green, yellow, blue, black, and white. These create the strongest signals in your opponent channels and are universally recognized across cultures. Research shows you can reliably use only 6 to 12 colors as codes before contrast effects make them indistinguishable. Size also matters dramatically. Small symbols need saturated, strongly contrasting colors to pop out, while large background areas should use muted, low-saturation colors. This prevents the background from distorting how we perceive the small colored elements. Understanding simultaneous contrast is also important. Colors change appearance based on their surroundings. The same gray square looks darker on a light background than on a dark one. This means you must always test your color choices in context, not in isolation. What makes these principles so powerful is their foundation in biology. They become practical tools precisely because they're rooted in how your visual system processes color. Does a picture really say more than 1,000 words? Some ideas are easy to express in words, but difficult to show visually. Others are simple to sketch out, but almost impossible to describe accurately. This mismatch between an idea and the tool used to communicate it creates a familiar kind of problem. For example, try to imagine explaining to someone how to assemble IKEA furniture over the phone. Frustrating, right? Now imagine you had to do it only drawing pictures, equally challenging. This reveals a fundamental truth about human communication. We need both visual and verbal elements working together, but each has its own superpower. The key finding from recent visual thinking research is that images and words aren't interchangeable. They're complementary tools that excel at different tasks. Words dominate when you need logic, conditions, and abstract reasoning. They handle the if this, then that thinking that drives everything from computer programming to giving directions. Visual elements shine when showing relationships, spatial connections, and patterns that would take paragraphs to describe in words. Take sign language, for example. It demolishes the myth that visual communication is somehow simpler than verbal. Sign languages are complete, sophisticated communication systems with their own grammar. They just happen to use visual patterns instead of sounds. This proves that the distinction isn't really about seeing versus hearing, but about two different types of thinking: symbolic logic versus pattern recognition. The most powerful communications combine both modes strategically. Take effective PowerPoint presentations. They work best when slides contain primarily visual elements, while the speaker provides the verbal narrative. The magic literally happens through pointing, that linking words to images. When a presenter says, "This trend shows," while gesturing to a specific part of a chart, they're creating a bridge between verbal and visual information. For practical application, remember these principles. Use words for conditional logic, sequences, and abstract concepts. Use visuals for showing relationships, spatial arrangements, and patterns. In presentations, minimize text on slides and maximize clear pointing gestures. When creating instructions or explanations, consider whether your audience needs to follow a strict sequence, favor words, or explore information freely, favor diagrams. The goal is to use pictures and words together, each doing its job. When they're combined well, they make communication clearer and stronger. Whether you're working on a website, giving a talk, or breaking down something complicated, it comes down to picking the kind of communication that suits the task. The future of good design. Did you know that Michelangelo's magnificent Sistine Chapel ceiling began not with grand visions, but with thousands of messy sketches? This reveals the core of human creativity. Our most powerful thinking often happens not in our heads, but through an interaction between mind and paper. The magic lies in what researchers call constructive perception. the ability to see meaning in meaningless marks. Take psychologist Manfredo Massironi's fascinating exercise. Draw a random scribble without thinking about anything specific. Now add just a small circle and a triangle shape to any loop in your scribble. Suddenly, a bird appears. This isn't just a party trick, it's how professional designers actually think. For many great designers, sketches become external thinking tools, allowing them to have a conversation with their own ideas. This process works because our brains excel at recognizing patterns. Our visual system's flexibility in interpreting marks is what makes sketching such a powerful thinking tool. The key insight involves balancing mental costs. While our immediate visual attention can only track a few items simultaneously, external sketches can preserve and develop complex ideas efficiently. Modern technology amplifies this ancient process. When researchers studied whale behavior, they initially used time-consuming 3D replay systems. But transforming the data into spatial ribbon displays allowed analysts to identify behavioral patterns dramatically faster. The lesson? Present information in the right visual format, and recognition becomes nearly effortless. The future belongs to hybrid human-computer thinking systems, where machines handle routine calculations while humans excel at flexible pattern discovery. The goal isn't to replace human creativity, but to create responsive tools that present exactly the right information at exactly the right moment. By linking new technology to what we know about our visual system, we can extend our natural creative abilities rather than constraining them. The main takeaway of this Blink to Visual Thinking for Design by Colin Ware is that understanding the human brain is the key to effective design. Human vision isn't the comprehensive camera we imagine. It's more like a selective search engine, processing only what we actively seek. This changes everything we think we know about effective design. For instance, our brain uses specialized filters to detect basic features like color and movement, making elements that differ in these simple ways instantly noticeable. Meanwhile, complex combinations require slow, effortful examination. Since we excel at recognizing 2D patterns over depth perception, flat visual hierarchies work best. Color coding succeeds only with high luminance contrast and bright colors like red, green, and blue. Images and words aren't interchangeable. They're complementary tools that excel at different cognitive tasks. The future belongs to designs that work with, not against, these fundamental patterns of human perception. Okay, that's it for this Blink. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next Blink.